In this video, we're going to go over rewriting exponential equations with equal bases. And this is kind of one of those math party tricks because it only works with problems where it's set up to work. Not every number can really be rewritten to be some different number to a convenient power that'll let this work. So it works in certain situations and doesn't work in other situations. And I'll talk about how to tell whether or not it's going to work as well a little bit. This is kind of the simplest example because most of us can see fairly quickly that 9 is 3 times 3. So I can take 3 to the x is equal to 9 to the something. Well, that would also be 3 to the x is equal to, I can rewrite this 9 as 3 to the second, like that. And, well, now I can use the power of a power property, which is one of our properties of exponents. And I can rewrite this as 3 to the x is equal to 3 to the 2 times 4, or 3 to the x is equal to 3 to the 8th. And now I've got the same base on both sides. And I could have done this in this step as well. I just chose to multiply this first. So x has to be equal to 8. So in this case, just by noticing that one number was a power of the other number, I was able to do this rewriting process. A lot of the time, though, it'll be a little less immediately obvious. And part of why that is the case is because we can't usually recognize all of the powers of something. If you're going to be doing a lot of this kind of work, you should just make yourself a chart. Here's one that I threw together in about, 10 minutes using Excel. I just did powers of 2, powers of 3, and so on. My chart goes up to 10, and it has exponents up to 10. So like that's 2 to the 10th, that's 3 to the 8th, and so on. Or 4 to the 8th, my apologies, and so on. And that lets me very quickly kind of look for my numbers in this table to see what power I can rewrite them as. And if I didn't have access to a tool like this, I might also start looking at, well, if it's an even number, maybe it's a power of 2 and guessing and checking using a calculator. So having some sort of reference material like this may help you if you're doing a bunch of these. Most students will eventually recognize this column, particularly if you do a lot of computer science classes as well. Powers of 10 are kind of the one everybody gets for free, because if you look at that column, or you remember back from learning about scientific notation in middle school, they're pretty easy to recognize. But all of the rest of the ones in here, I recommend having some kind of reference if you're going to be doing a lot of these, because it isn't something that most people will have memorized. So let's try one out that is a little less straightforward. I have 4 to the x is equal to 8 to the 5th. I might immediately recognize these both as powers of 2. 8's not a power of 4, because if I count powers of 4, it'd be 4 squared is 16. So it's definitely not possible to rewrite this as a power of 4 that's like a whole number power that makes sense. But these are both powers of 2, and I probably just know my powers of 2, but if I don't, I could look on reference material like this, and I would see, oh, 4 is 2 to the second, 8 is 2 to the third, so I can rewrite these as 2 to the second x and 2 to the third 5. And it's okay if you need reference material for this. I do think powers of 2, if you're going to memorize something, they will come in handy more often than a lot of other math facts. Particularly, you will see them show up a lot when dealing with computers because of binary. And I keep these in parentheses because this whole idea of 2 squared is the same as 4. And this whole idea of 2 to the third is the same as 8. And so now I can use the power of a power property on each side and get 2 to the 2 times x is equal to 2 to the 3 times 5. And I can either resolve this multiplication now or do that after I drop the bases. It does not matter. I tend to like to clean it up before I drop the bases, but that is just a style thing. So I have 2x, 3 times 5 is 15. So I have 2x is equal to 15. And if I divide both sides by 2, x is equal to 15 halves, or that is 7.5. So I might have 7.5 depending on what I'm doing next with my information. There are some reasons you might want to keep this as an improper fraction. It really just depends on if you're doing a larger problem, what do you need to do with your information next? So I think that's kind of enough examples of just I have some number and I need to kind of hunt that down. But there are a few other properties of exponents that can come into play that can make things a little more challenging to see that that's what you're supposed to be doing. So I might have something like 1 over 216 is equal to 36x. So it's important to remember the rest of your properties of exponents and remember kind of the relationship between fractions and negative exponents and realize that the first thing I should do is see, once again, if I can write that as some kind of power of something. And I might remember that 6 times 6 is 36, so that a good place to start looking would be to see if this is perhaps also a power of 6. So I look in my powers of 6 column, and it is. 6 to the third is 216. So I can rewrite this as 1 over 6 to the third is equal to 6 to the second to the x. I could have put this in parentheses, but this is already a grouping symbol. So since the whole bottom is all in that to the third, I don't need to put in an extra grouping symbol. And then I know I can rewrite any exponent that's on the bottom of a fraction as a negative exponent. So I can rewrite this as 6 to the negative 3. And then on this side, this would be 6 to the 2x. Well, now I have the same base. So I know negative 3 is equal to 2x. I can divide both sides by 2 and get that x is equal to negative 3 halves. One more example that I want to use to bring up another property of exponents, because this is, again, kind of where students start to get thrown, is when you start getting things like this that don't necessarily look the same. Because it didn't look like it might be the same until this step, and to be comfortable with this rewriting. If I have the square root of 125 is equal to 625 to the x. Well, looking at that offhand, I'm just kind of like, what garbage is this? I don't like either of those numbers. They're pretty big. My first clue in terms of where to look is that they both end in 5s. So that's a good clue that they might be powers of 5. And I might or might not remember that that's 5 cubed. So once again, I'm looking on some reference material where I have the powers of 5 listed. This isn't something that necessarily everyone would have memorized. And I can rewrite this as the square root of 5 cubed. And I can rewrite this as 5 to the 4th. And Well, that's getting closer, but there's a square root here. So I also need to use another property of exponents involving square roots to rewrite this. I know this is secretly to the second power there because there's no symbol there. So I can rewrite this as 5 to the 3/2 power. And that's just another property of exponents. I'm not going over why these properties of exponents work in this video because that feels like it should be a different video. But if that is something you are having trouble with and you are in my class, please come to office hours, and perhaps I will make a video on that eventually. So now I have same base, and somehow that turned into a, oh, I see what I did wrong. Hey, I forgot to keep my x there. I made a goof. Now I have a variable, and I didn't just end up with 3/2 is equal to 4, which it blatantly is not. Good for me. So 3/2 is equal to 4x, and I can once again divide by 4, or conceptually here, maybe it's easier to think of it as multiplying by 1/4, which would do the same thing here. And the reason that might be conceptually more simple for a lot of you is that if I multiply this by 1/4, that'll still be 1, and multiplying this by 1/4 is a little easier to see. That'll be 3/8. So 3/8 is equal to x. Because that would be like 4/1. So those are some different strategies you can use, and they really only work when they're powers of the same number and you have to kind of go hunt down which powers and rewrite. So this is one of those things that works if the problem is set up for it to work. So one of the things you can do is take a look at these different columns in these tables of powers to kind of get your intuition going so that you can start recognizing when this is probably a strategy you can use instead of logarithms, and just notice things about like how powers of 2 look, how powers of 5 look, how powers of 10 look, so that you start to get that intuition like, oh, well, these end in 5. I should check if they're powers of 5. Or you just start going, 128, I know you're a power of 2. I just don't remember which one. And you can kind of start building that intuition.